Are you ready? This is exciting math for kids, and it's going to be a great time. You know, math isn't boring. It's not a time to get a little nap in. We are going to show you that math is fun. First, we are going to take a look at addition. That is a great starting point. You may have already seen our basic addition video. In that video, we learned that addition means putting numbers together, and we learned about this lady named Sally who collects golf balls. Let's say Sally starts her day off with 2 golf balls. Cool. And then she finds another golf ball, so now we get to find out how many she has in total. She had 2, and now she's got another one. How many golf balls does she have? This is addition. 2 plus 1. Can you add those up? What's 2 plus 1? 3. Awesome. Let's look at one more example of basic addition before we get into the double-digit addition. Let's say later on in the day, Sally has 5 golf balls, and then she finds 2 more that are just sitting there, so she can add the 2 golf balls to the 5 that she already has. Remember, addition is putting numbers together. 5 plus 2 equals what? Here's a hint. You can count these golf balls up and get the answer. Yeah, 7. 5 plus 2 equals 7. You are doing a tremendous job. These are examples of single-digit addition. But what if we need to add bigger numbers? Let's say there's this kid named Travis. Hi, Travis. Travis collects these. What are these called? Marbles. Travis collects marbles. Travis had a lot of marbles. He had 54 marbles. But today's his birthday, and someone just gave him 21 more marbles. Wow! And now he wants to know, how many marbles do I have? I had 54, and now I have 21 more that are in my collection. How many marbles do I have? That's the question that Travis has. What's 54 plus 21? Now here's the deal, Travis. You could count each of the marbles one by one to figure out exactly how many you have now. But that would take a long time. Look at all of these marbles. There has to be a better way. In fact, there is. There's a way that is super fast and super fun. We can add 54 and 21 together by doing a fun trick. We'll turn these big numbers that are difficult to add on their own into smaller numbers. What you will do is you will add the numbers to the right here, which are the ones. To make it easier, we are going to block the 10 spot for right now with this nifty blue rectangle. Suddenly, this huge big addition problem has turned into a simple, fun addition game. So we add the right spot, the ones spot together. What is 4 plus 1? Yes, 4 plus 1 equals 5. So we'll write 5 under the 4 and the 1. Awesome job. We're halfway done already. Next, we will add the 10s together. The 10 spot is to the left. The 2 numbers in the 10 spot are the 5 and 2. To make it easier, we are going to block the 1 spot with another blue rectangle because we already added the 1 spot up. What is 5 plus 2? 5 plus 2 equals 7. So we will write 7 under the 5 and the 2. So what is our answer? What is 54 plus 21? You can see it right here. 75. 54 plus 21 equals 75. The answer to an addition problem is called the sum. Our sum is 75. It's simple. With double-digit addition, you add the right side, the ones, together first. Let's figure out what 30 plus 12 is. First, what is 0 plus 2? Yes, 0 plus 2 is 2, so we'll write a 2 under the right side, the ones side. We've almost arrived at our answer already. Then we add the left side, the tens, to get our answer. What is 1 plus 3? Yep, 1 plus 3 equals 4. So the sum of this addition problem is 42. 30 plus 12 equals 42. Let's try a different type of addition problem. 33 plus 6. This is an interesting one because 33 is a double-digit number, but the number 6 is a single-digit number. But we use the same fun trick as before. First, we add up the ones. What is 3 plus 6? 3 plus 6 equals 9. So we write 9 here under the ones. Next, let's add up the tens. But there is only one number in the 10 spot. So what do you get if you add nothing to 3? You get 3. So what is our sum? Yes, our sum is 39. How are we doing? Double-digit addition is pretty cool, isn't it? Now we are going to talk about something special, really special. Special like seeing an owlet, a little baby owl looking at you, looking at your eyes. You know? So cute, so cute, so special. So what is this special thing we are about to learn? Well, sometimes something sneaky happens. Let's show you. Let's say we are adding 17 plus 15. We of course start with the right side, adding up the ones first. So what is 7 plus 5? Do you know? 7 plus 5. Yeah, 7 plus 5 equals 12. That's right. But there's only enough room for one digit under the 7 and the 5. So what do? Well, we do a super cool move called regrouping. Regrouping is awesome. Remember, the sum of our ones column is 12. 7 plus 5 equals 12. So we have to regroup the number 12. But what does that mean? What does regrouping even do? Well, regrouping splits the digits and puts them in different places. Now that might sound weird, but we're going to show you how it works. It's super simple and fun. Regrouping the number 12 is easy. All we do is split the digits, putting the 2 under the ones, and carrying the 1 with the tens up here. That's it. Then we add up the tens. What is 1 plus 1 plus 1? Yeah, 1 plus 1 plus 1 equals 3. So we write 3 under the tens. And now we have our answer. 17 plus 15 equals 32. 32 is our sum. Remember, regrouping is only used when there is a double-digit number, but there is only space for one digit, like our example, 7 plus 5 equals 12. But there wasn't enough room for both numbers, so we keep the 2 under the ones and carry the 1 to the tens. Hey, let's practice by playing a game. The game is called, Do We Need to Regroup? This is probably the most exciting double-digit addition game ever. Hosted by our very own Mr. Whiskers. Thanks for helping us out. You're not going to help us out. Okay. Okay, now this is embarrassing. Okay. Fine. Okay. All right. That's okay. That's all right. It's all right. Okay. It's okay. All right. Well, we are going to look at double-digit addition problems, and you are going to let us know, do we need to regroup? Here is our first problem, 32 plus 19. You already know the question. When we add 32 and 19, do we need to regroup? Yes, because 2 plus 9 equals 11, which is a double-digit number. Remember, the first step we take is adding up the ones. But if the sum is a double-digit number, that means we need to regroup. Great job. Let's go ahead and finish the problem. When we regroup, we split the digits. So the first one gets carried, and the second number, in this case, also the number 1, stays down under the ones. Then we just add up the tens. What is 1 plus 3 plus 1? 5. So, 32 plus 19 equals 51. And yes, we did have to regroup. Here is our second one, 56 plus 22. This is the question. When we add 56 and 22, do we need to regroup? No, because 6 plus 2 equals 8, and 8 is a single-digit number that can fit under the ones. Remember, the first step we take is adding up the ones, and since the sum is a single-digit number already, we do not need to regroup. Fantastic. Let's go ahead and finish the problem. So when we added up the ones, our sum was 8. We'll put the 8 under the ones. Then we just add up the tens. What is 5 plus 2? 7. And we have our answer. 56 plus 22 equals 78. And no, we did not have to regroup. Here is our next one, 34 plus 25. This is the question. When we add 34 and 25, do we need to regroup? The answer is no, because 4 plus 5 equals 9, and 9 is a single-digit number that can fit under the ones. Remember, the first step we take is adding up the ones, and since the sum is a single-digit number already, we do not need to regroup. Well done. Let's go ahead and finish the problem just for fun. So when we added up the ones, our sum was 9. We'll put the 9 under the ones. Then we just add up the tens. What is 3 plus 2? 5. And we have our answer. 34 plus 25 equals 59. And no, we did not have to regroup. This is our last one. You have been doing great. 43 plus 37. You already know the question. When we add 43 and 37, do we need to regroup? Yes, because 3 plus 7 equals 10, which is a double-digit number. Remember, the first step we take is adding up the ones, but if the sum is a double-digit number, that means we need to regroup. Wonderful. Let's go ahead and finish the problem. When we regroup, we split the digits. So the number 1 gets carried, and the second number, in this case, the number 0, stays down under the ones. Then we just add up the tens. What is 1 plus 4 plus 3? 8. So 43 plus 37 equals 80. And yes, we did have to regroup. That's tremendous. Now would be a great time to look at what is the opposite of addition, subtraction. Yeah. You may have watched our basic subtraction video where I gave away my hats, including Hattie. It got emotional, okay? It just did. And in that video, we learned that subtraction is when you take numbers away. Let's say I have 6 hats, and there's no way that I need 6 hats that look exactly the same. Well, good news. 2 of my friends need hats, and I decide to give 2 of my hats away. When you take numbers away, remember that is subtraction. If we were to write it out, it would look like this. 6 minus 2. So, how many hats do I have now if I take 2 away? Yes, the answer is 4. I have 4 hats now. Now this is interesting. The answer to a subtraction problem is called the difference. Can you say that with us? The difference. Yeah, the answer to a subtraction problem is called the difference. That means in our example, the difference is 4. So, subtraction is just taking numbers away, and the answer to a subtraction problem is called the difference. Now that we have that, we want to look at bigger numbers, double-digit numbers. Let's say we have a lot of blueberries. For some reason, they're just hanging out on a wooden table. We need to wash them and put them in a bowl. Let's pretend that when we were putting them in the bowl, we counted them and found that we had 66 blueberries. That's a lot of blueberries. You and your friends are hungry and blueberries are super yummy, right? So you and your friends eat 54 blueberries. That's right. These are some big numbers, some double-digit numbers. To find out how many blueberries we have left, we simply subtract 54 from 66. Let's look at how that's done. Here is our subtraction problem again, 66 minus 54. With double-digit subtraction, all we do is break this big problem up into 2 little problems. First, we will subtract the right column, the ones. To make it a little easier, we are going to cover the tens column with this blue rectangle. Suddenly, this big subtraction problem is a really easy one. What is 6 minus 4? Do you know? Yes, 6 minus 4 equals 2. So we put the number 2 under the ones column, the right side. Great job. We are halfway to our answer. Next, we will subtract the left column, the tens. And this time we're going to cover up the ones column to make it a little easier. So, what is 6 minus 5? 6 minus 5. 6 minus 5 equals 1. We will write 1 under the tens, the left column. And just like that, we have our answer. The difference is 12. There are now just 12 blueberries. All right, let's do another one. How about 87 minus 53? This should be fun. First, subtract the right side, the ones. What is 7 minus 3? Yes, 4. So we will write 4 under the ones. Simple. Next, we just subtract the left side, the tens. What is 8 minus 5? Yes, 3. So we write 3 under the tens column. And we have our answer. The difference is 34. Double-digit subtraction is simple. First, subtract the right, the ones. Next, subtract the left, the tens. Then you have your answer, which is also called the difference. Now, there is something interesting that can happen when you subtract larger numbers. Here, we'll show you. Say we have this subtraction problem, 22 minus 17. Let's follow the process. So first we subtract the ones. What is 2 minus 7? Well, here's that interesting thing we mentioned to you. Say I have 2 carrots, and I need to give 7 carrots away. That's a problem. It's hard to give away more than you have. So what do? Well, we do a special trick. No, not this kind of trick. Wow, he is really high up there. No, not this kind of trick either, alright? It's a math trick, okay? It's a math trick. This is a subtraction video after all. The trick is called regrouping. Can you say that? Regrouping. Yeah, regrouping. When you are subtracting a column and the bottom number is bigger than the top number, that means you need to regroup. Just like in this example, because it is hard to take away more than you have, and 7 is bigger than 2, so we need to regroup. So how does this regrouping trick work? It's really easy. All you do is borrow 1 from the tens column. What is 2 minus 1? Yeah, 1. So this number in the tens column becomes a 1. And that 1 that we borrowed from the tens, it goes to the ones. It gets placed on this 2 in the ones column. And now the ones column is 12 minus 7. Now we just have to follow our subtraction game plan. We subtract the right column, the ones first. What is 12 minus 7? Yes, 12 minus 7 equals 5. So we write the number 5 under the ones column. Then, of course, we have to subtract the tens. But regrouping made this super easy. What is 1 minus 1? Yes, 1 minus 1 equals 0. So our answer is simply 5. 5 is our difference. Remember, when you are subtracting a column and the bottom number is bigger than the top number, that means you need to regroup. And with subtraction, regrouping means borrowing. In double-digit subtraction, regrouping is when you borrow 1 from the tens column. Let's try one more double-digit subtraction problem and see if we need to use the special regrouping trick. 43 minus 25. This is going to be awesome. Remember, the first thing we do is subtract the right column, the ones. But, 5, the bottom digit, is bigger than 3, the top digit. Time to regroup. So we borrow 1 from the tens column. What is 4 minus 1? Yes, 3. Then we put that 1 in front of the 3 in the ones column, making it the number 13. Then we just follow the process, subtracting the ones column first. What is 13 minus 5? What is 13 minus 5? Yep. It is 8. So we will write 8 under the ones column. Now it's time to subtract the tens. What is 3 minus 2? What is 3 minus 2? You got it. 3 minus 2 equals 1. So we put the number 1 under the tens column, and we have our answer. 43 minus 25 equals 18. 18 is the difference. We've learned a lot, but we need to make sure we are able to remember everything. Here's an idea. There's this guy, Mummy, who doesn't know how to do double-digit subtraction, okay? So we are going to do a double-digit subtraction review by teaching Mummy. It's simple and it's fun, Mummy. You'll love it. So, Mummy, subtraction is when you take numbers away. Sometimes subtraction problems can have little numbers, or other times subtraction problems can have bigger numbers, double-digit numbers. Here's how it works, Mummy. First, subtract the right column, the ones. Next, you subtract the left column, the tens. Then you have your answer, which is called the difference. Sometimes the bottom digit is bigger than the top digit in the ones column. This is something to get excited about, Mummy. It means you can use a special trick called regrouping. You just borrow 1 from the tens column and move it to the ones column. Then just follow the plan. Thanks for helping us teach Mummy. He looks happy? Cool. You know, there are so many great things about math. One of those great things is that you get to do a lot of amazing things with shapes. Let's take some time to look at all of the two-dimensional shapes. We are going to investigate them one by one. We're going to take you on a journey to discover the 2D shapes, the easy ones and maybe some of the ones that maybe you don't know yet. Some of the 2D shapes are super easy, and you'll be like, I know all of these! But then some of the other shapes are a little more tricky, and it's like, I don't know if I've learned this before. Wait, can we all agree that was a very weird sound, and we should just probably never record that kind of sound again? Yeah, that was not good. All right, 2D shapes! Let's go back to that. Okay, so let's start here. The trusty circle. We love the circle, right? You gotta love circles. Circles are cool. This is what a circle looks like. Here it is, your basic circle. You know, this is what a circle looks like. It looks like a really big dot, doesn't it? Next, let's look at this shape. This shape is a triangle. A triangle. This is very interesting. Okay, here it is again, the triangle. The triangle. Now, triangles are easy to spot, not just because you can learn what this shape looks like this. You can actually count the sides of the shape to discover that the shape is a triangle. So let's count the sides together. 1, 2, 3. This shape has 3 sides. A triangle has 3 sides. Not all triangles look the exact same. Look at this triangle. We know that this is a triangle because of its sides. Let's count them together. 1, 2, 3. There are 3 sides. Every triangle has 3 sides. It just looks more squished than the other triangle, but it's still a triangle. Now here is something very interesting, Let's say we took the triangle and we stretched it out. It's still a triangle, right? But if you did the same thing to the circle, if you stretched out that circle, it actually becomes a different shape. A shape called what? Yeah, an oval. An oval, when you stretch out a circle, it becomes an oval. And that's our third shape. Here it is again. An oval. An oval. An oval is a stretched out circle, basically, right? An oval. You've seen these around, right? Can you say that with us? Oval. Oval. Good. Let's look through these three shapes again just to make sure we really know them. What is this shape? Yeah, a triangle. What's this shape? Do you know? Yeah, it's an oval. What's this shape? Yeah, a circle. Okay, what is this shape? Yeah, it's an oval. What is this shape? Uh-huh. It's a triangle. What is this shape? Yeah, a circle. Now we're going to get help from our friend Clarence, who's going to show us the next four shapes. Okay, the next four shapes all have one thing in common. They have four sides. Four shapes that have four sides. So let's meet these shapes. The first one is this shape. This shape is a square. A square. A very common, very popular shape. The next shape is this shape. What is this shape? Do you already know? Yeah, a rectangle. A rectangle. The next shape is not as popular, and you might not be familiar with it. This shape is a trapezoid. Oh, that's a fun word to say. Can you say trapezoid? Wow, trapezoid. And the final shape is this one, which is a parallelogram. Wow, parallelogram. First, let's look closer at the square, okay? The square has four sides, of course, but all four of the sides are the same length. Okay, so it looks like a perfect box, doesn't it? A square has four sides that are all the same length. Next, we're going to take a closer look at the rectangle. Yeah, rectangles are pretty cool. They are usually drawn like stretched out squares, aren't they? It almost looks like a square that's been stretched out. But a rectangle is any shape that has four sides and has four corners that look like these. And they're usually drawn like this, so they could be drawn differently. They're usually drawn like a stretched out square. Next, we are going to take a closer look at the trapezoid. What a cool shape name, trapezoid. Two of the sides are parallel to one another, and the other two sides are not. That's what makes a trapezoid a trapezoid. You might be wondering, what does parallel mean? Well, let's show you. We'll show you with these lines. These lines are parallel to one another. Parallel lines are the same distance apart at every point. They never move closer or further away. Let's look at our trapezoid again. The top side and the bottom side, those are parallel to one another because at every point they're the same distance from each other, aren't they? But what makes a trapezoid so unique is look at these two sides. These two sides are not parallel to one another. They're actually moving apart as you move down the shape, don't they? Those sides are actually moving away from one another. They are not parallel to one another. That's what makes this shape a trapezoid. Okay, Clarence, we hope you're ready. The last four-sided shape that we're going to be looking closer at is the parallelogram. And as the name might suggest, it's named after the fact that the opposite sides of the parallelogram are always parallel to one another. That's what makes a parallelogram a parallelogram. A parallelogram can be drawn in many different ways, but this is the most popular way to draw a parallelogram. To draw it almost like a rectangle that is having the wind blow really fast towards it, so it's almost bending backwards. It's almost looking like a slanted rectangle. That is the way that a parallelogram is usually drawn. Okay, so what's this shape? Do you remember? Yeah, a square. And what about this shape? Uh-huh, a rectangle. What about this shape? Uh-huh, it's a parallelogram. And what about this shape? What's this? Uh-huh, a trapezoid. Hey, Clarence, thanks for helping us with... Oh, are you brushing your teeth? Oh, okay. Well, good for you. That's awesome. Thanks for helping. And wow, it's important to brush your teeth. This is great. I didn't know bears brush their teeth, but that's phenomenal. That's great. All right, we've got more shapes to cover here. We gotta go. Sorry, Clarence. We're gonna leave your bathroom now. We only have 3 more shapes to show you. The first is the pentagon. The pentagon has 5 sides. Next is the hexagon. The hexagon has how many sides? 6. 6 sides. A hexagon has 6 sides. And the final shape we're showing you today is the octagon. The octagon has 8 sides. 8 sides. You've seen these shapes before. Have you ever played soccer? Yeah, you see 2 of the shapes in a soccer ball. The white panels are hexagons. Each white panel is a hexagon. And you can see there are 6 sides for each white panel on a soccer ball. And each black panel is a pentagon. There are 5 sides for every black panel on a soccer ball. A soccer ball is covered in hexagons and pentagons. You've also seen octagons in real life. Have you ever noticed that a stop sign is an octagon? Yeah, a stop sign is an octagon. It's a shape that has 8 sides. Hey, a special thumbs up to you. You've done a great job. In fact, you've done so well. We're gonna quiz you. Yeah, it's quiz time. It's quiz time. I hope you're ready. It's quiz time. We're gonna find out how many of these shapes you can remember that you know. It's gonna be awesome. You're gonna do great. You've been paying attention. Okay, what is this shape? If you need to count the sides, go ahead. What is this shape? This shape is an octagon. Good job. Okay, here's the next one. What is this shape? What is this shape? Do you remember? A trapezoid. Yeah, what a fun name to say. Trapezoid. This is a trapezoid. 2 of the sides are parallel to one another, and the other 2 sides are not parallel to one another. Okay, let's try this shape. What is this shape? If you need to count up the sides, what shape is this? Great job. A pentagon. A pentagon has 5 sides. Great job. Okay, you're doing a great job. How about this shape? Okay, how about this shape? What shape is this? Yeah, a triangle. A triangle. We know it's a triangle because it has how many sides? 3. A triangle has 3 sides. Well done. All right, let's give this shape a whirl. What shape is this? What shape is this? Looks pretty cool, but what shape is it? Do you remember? A parallelogram. That one's fun to say too. Parallelogram. Can we say that together? A parallelogram. Oh, you can say it louder than that. Parallelogram. Oh, come on. One more time. One more time. Parallelogram. Great. A parallelogram. All right, here is the last shape that we're going to quiz you on. What is this shape? You can count up the sides. What kind of shape is this? Wow, impressive. Yeah, this is a hexagon. We know it's a hexagon because it has how many sides? 6 sides. Yes, wow, very impressive. That is so impressive. Well done, that's great. This is a hexagon because it has 6 sides. So much fun. Hey, we've talked about addition, subtraction, and the shapes. Next, we're going to learn about multiplication. Then we're going to use that multiplication to do something cool with shapes. You see, multiplying is like being a detective. You're cracking a code, which is so cool. You're solving mysteries, like legit mysteries. Like I'm in an office building right now. There's a cake behind me. For some reason, I'm looking out right now at you guys, and I see that you're like, whoa, we're gonna multiply. And once you learn, it's just a game, so buckle in for the fun and the learning. Let's say you have 2 bikes, and for some reason they look the exact same, and somebody wants to give you an air pump. They ask a simple question: how many tires do you have to take care of? To figure that out, we're going to use multiplication. We're going to play the game. It's going to be awesome. Okay, so here is how multiplication works. So we put the number that's in each group, and then we put this X, which means times, and then the number of groups. So that tells us how many times that number is going to show up, and then we add them all together, and you've got your answer. Isn't that cool? And just a side note, to work, there has to be the same number in each group. Now remember, we're trying to figure out how many tires you have to take care of if you have 2 bicycles. Alright, now we have the wheels under each bike. Each bike has 2 wheels. 1, 2. So we write down a 2. Each bike has 2 wheels. Remember, the first number we write down with multiplication is the number in each group. Then we write an X. This X means times. 2 times. It's the symbol of multiplication. Alright, the second number we write are the number of groups. You can see them here. How many groups do we have of 2? How many? Yeah, 2. So it reads 2 times 2. To figure this out, we are going to skip count by 2. 2, 4. That means 2 times 2 equals 4. If you have 2 bikes, that means you have 4 wheels. 2 times is 4. Remember, this is how multiplication works. The number in each group times the number of groups equals your answer. Of course, to work, there has to be the same number in each group. Alright, let's take this to the next level. Let's say someone has 4 bikes. And here are their wheels. Woohoo! Yeah! You know how to do this now. Each bike has 2 wheels, so the first number we write down is the number 2. That's the number in each group. We're going to put the time symbol there and count the number of groups. 1, 2, 3, 4. So it's 2 times 4. This is so much fun! This is multiplication! Now let's skip count to get the answer. 2, 4, 6, 8. 8 is our answer. There are 8 wheels. 2 times 4 equals 8. This is how multiplication works. We put the number in each group times the number of groups, and we get our answer. You're getting the hang of it. Alright, let's try this one. Let's say you buy 3 packs of trading cards. Let's say each pack had 5 cards in it. That's a pretty good amount. So 3 packs of 5 cards. How many cards did you get in total? That's a really great question. Sounds like we're going to need to multiply. So each group has 5, so that's the first thing we write down, the number in each group. That's 5. Put the multiplication sign, which is the X, which means times. 5 times... How many groups are there? 1, 2, 3. So the second number is 3. 5 times 3. What's 5 times 3? We're going to skip count to find out. 5, 10, 15. 5 times 3 equals 15. You have 15 trading cards. Alright, this is how it works. You take the number in each group times the number of groups and you get your answer. Now here are some multiplication tricks that are going to be really sneaky ways that you can figure out multiplication problems really quickly. Here's the trick. If you multiply any number by 0, you always get 0. Always, you always get 0. Here's an example. 5 times 0 equals 0. When you have 0 groups of 5, that means you have 0. There are none. Whenever you multiply any number by 0, you always get 0. 100 times 0 equals 0. Even if 0 is the first number in the equation, you still always get 0 when you multiply by any number. For example, 0 times 11 equals 0. And 0 times 1,000 equals 0. If you multiply any number by 0, you always get 0. Oh, this has been so much fun. Here is the next trick. If you multiply any number by 1, it stays the same. Look at these. 7 times 1 equals 7. 100 times 1 equals 100. 33 times 1 equals 33. If you flip them, the answer stays the same. 1 times 7 equals 7. 1 times 100 equals 100. 1 times 33 equals 33. Honestly, the order of the multiplied numbers does not change the answer. If you were to flip the number of groups and the number in each group, you would still get the same answer. Though we still recommend this way. So simple. The number in each group times the number of groups to get your answer. So the two tricks have been, if you multiply any number by 0, you always get 0. And if you multiply any number by 1, it stays the same. The final multiplication trick is to use multiplication tables. They come in all shapes and sizes, but they are all helpful, especially as you're first learning how to multiply. Here are some examples of multiplication tables. There's a table for all of the numbers from 1 to 10. Some kids memorize tables like these so that they'll know right off the bat in a moment what an answer could be for certain multiplication problems. This is how multiplication works. The number in each group times the number of groups gives us our answer. Amazing. Now, we talked about multiplication and promised that we would be able to use it to do something cool with shapes. Next, we are going to talk about finding the area of a shape. Whoa! In this video, we are going to learn about area. It's going to be fun. But first, we want to hear from you. 6-year-old Hannah from Maryland said, "My favorite video is on place values. We are so glad you enjoyed it. Place values are awesome." We also heard from Mrs. Yablonsky's second grade class in Pittsburgh who watched our sentence fragments video and said, "We loved the video, especially Mr. Whiskers. It was funny and we also learned something too." That's great. We love to hear that. We love hearing from all of you. Be sure and watch this video to the end to learn how you too could be featured on one of our videos. Well, as we mentioned earlier, in this video we are going to learn about area. Area is something we can discover about shapes. The area of a shape refers to how much space is inside of it. Area is very different from perimeter. If you'll remember, perimeter is the space around a shape. Area is the space inside of a shape. Alright, so area is the space inside of a shape, and perimeter is the space around a shape. So they're very different, aren't they? And this video is all about area. We're going to learn how to find the space inside of a shape. This should be fun. Let's play a game called What's the Area? We want to find the area of this shape. What kind of shape is this? Yeah, a square. Remember, the area of a shape is the space inside of the shape. We are going to measure the area of the shape using square units. So, the area of the shape is how much space is inside of it. So, how many square units are inside of this square? Do you know? If you don't, just count them up. Yeah, 4. There are 4 square units in this square. 4 square units is the area of this square. Okay, that was cool, right? Let's try figuring out the area of this rectangle. Just like last time, we are going to measure the area of this rectangle using square units. Remember, the area of a shape is the space inside of the shape. So, how many square units are in this rectangle? Do you know? Yeah, there are 5 square units in this rectangle. Great job! That's the area of this rectangle. 5 square units. Awesome. Now we are going to look at an irregular shape. What is the area of this shape? Just like we did with the others, we are going to measure the area of this shape using square units. How many square units are inside of this shape? Feel free to pause this video to give yourself time to count them. Were you able to count all of them? How many square units are in this shape? What is the area of this shape? Yeah, 12 square units. Great job. There are 12 square units in this irregular shape. So far, finding the area has been very easy because we've shown you the inside of the shape, so all you have to do is count how many units are inside. But what if you can't see the units inside the shape? What if there are just numbers that you know and you have to come up with the area another way? Here is the fun part. To find the area of a shape, you have to use multiplication. Yeah, multiplication! So, how do you find the area of a square or a rectangle using multiplication? All you have to do is multiply the length times the width to get the area. Here, we'll show you. Let's say we want to find the area of this rectangle. It is 6 feet long and 1 foot wide. Remember, to find the area of a square or a rectangle, all we have to do is multiply the length times the width. The length times the width is the area. It's just simple multiplication. So we would write 6 times 1. 6 times 1 will give us the area of this rectangle. What is 6 times 1? Do you know? Yeah. 6 times 1 is 6. Whenever you multiply a number times 1, it stays the same. So our answer is 6 feet squared. That little 2 next to feet means squared. It tells us that the rectangle has 6 square feet of space inside. The area is 6 feet squared. Why don't we try another one? Let's say we want to find the area of this square. It is 3 centimeters long on each side. Remember, to find the area of a square or a rectangle, all we have to do is multiply the length times the width. For a square, the length and the width are the same size, aren't they? Well, the length times the width is the area, so we just have to multiply. We would write 3 times 3. 3 times 3 will give us the area of this square. What is 3 times 3? Do you know? Yeah, 3 times 3 is 9. The area of this square is 9 centimeters squared. That little 2 next to centimeters means squared. It tells us that the square has 9 square centimeters of space inside. That was so cool. What about this rectangle? What is the area of this rectangle? As you can see, it is 4 meters long and 2 meters wide. Remember, to find the area of a square or a rectangle, all we have to do is multiply the length times the width. The length times the width is the area. It's just simple multiplication. So we would write 4 times 2. 4 times 2 will give us the area of this rectangle. What is 4 times 2? Do you know? Yeah, 4 times 2 is 8. So the area of this rectangle is 8 meters squared. That little 2 next to meters means squared. It tells us that the rectangle has 8 square meters of space inside. As we are wrapping up, we want to share 2 quick tips about area. As you saw from our examples, when you find the area of a shape, the answer is always squared. If we discovered the area of a shape was measured in feet and the answer was 50, our answer could be written 50 square feet or 50 feet squared. The answer is always squared because area tells us how much space is inside a shape. The little 2 means squared. The second thing we want to mention is that you have to use a different multiplication equation to find the area of circles and triangles. In this video, we just learned the basics of area and how to find the area of rectangles and squares, but this is just the beginning and the start of an exciting math world. There is so much more about area to learn. How much fun was that? Thanks for watching this video to the end. We hope you enjoyed learning math with us today. Math really is exciting. Don't forget to say hello to us in the comments and let us know what your favorite part of this video was. We think you are awesome, and we hope to see you next video. This is the end, but don't cry. You know, there's a circle in the middle of the screen that's popping up. You can click that to subscribe if you haven't already, and there are 2 special videos that you can check out. You could just go straight to those or, do whatever you want, in internet land, but why not learn more? We have so many more videos. All right, so we hope to see you there, okay?